Math 20s, this is the second video for lesson 2.1, angles and standard position. First, I just want to start with a quick vocabulary thing that I probably could have put in the prereq lesson. 3 different sides, 3 angles that are all different, scalene, triangle. 2 that are the same, which means 2 angles are also the same, is called isosceles. And equilateral is when all 3 sides are the same, which makes all angles the same. And since the angles have to add up to 180, it means that they must all be equal to 60 degrees. So we're going to talk about something in this lesson called the special triangles. And these turn out to be shockingly important to not just Math 20, but especially in Math 30 and beyond. So there are 2 special triangles. One of them has 45, 45, 90. So a 45 degree angle, a 45 degree and a 90 degree angle. And the second has 30, 60, and 90. But we'll get to that one in a second. Let's talk about 45, 45, and 90. So the simplest I could think of, so first of all, 2 of these sides are the same, which makes this an isosceles triangle. So if I make the 2 legs of this triangle equal to 1, make that one 1 and that one 1. If I just do Pythagoras, 1 squared plus 1 squared is 2. So the hypotenuse ends up being the square root of 2. Now that might not seem that exciting or important, but it means that I could set up SOHCAHTOA, sine, cos, and tan for a 45 degree angle. I say, okay, so sine of 45 must be opposite over hypotenuse, so it's 1 divided by root 2, or root 2 over 2, which is exactly correct. And the important thing about that is that it's an exact value. If you punch sine 45 into your calculator, you'll get the decimal approximation of that, 0.7071. But our TI 83, 84 calculators don't do 1 over root 2 or root 2 over 2. Turns out because this triangle is isosceles, 2 sides are the same, that cos 45 gives you the exact same answer, 1 over root 2 or root 2 over 2. And tan, even nicer than all of that, and the calculator will agree with this one, tan is equal to 1 over 1, which just equals 1. Now, for the 30, 60, 90, imagine we started with an equilateral that had sides that were 2 and obviously angles that are 60. But I cut that right in half, right down, slice it right through the middle. Well, I would still have a 60 degree angle at that one top angle, and the top side there, which now has become a hypotenuse, would stay 2. But the side on the right there is 1. And if I do Pythagoras from there, 2 squared minus 1 squared, I realize, oh, this bottom one is root 3. So again, I have a square root involved, which means if I do SOHCAHTOA for 30 or 60, I'm going to have some root 3's involved. Now, the simplest sine of 30, no need. 1 over 2, exactly a half. Your calculator will even say sine of 30 equals 0.5 exactly. But cos of 30 is not a nice number. Cos of 30 gives you the square root of 3 divided by 2, which is the best answer. If you were to approximate that one, it's about 0.866 decimal, awful decimal number, which is what your calculator will give you. And tan as well has that root 3 involved because it would be 1 divided by root 3. If you rationalize it, you've got root 3 over 3. The decimal goes on forever and ever, irrational number, so this is the best answer to leave it as a square root of 3. Now, because 30 and 60 fit in the same triangle, it turns out that the numbers for 60 look awfully familiar. Sine of 60 is root 3 over 2. Cos of 60 is 1 over 2. So in other words, you switched the values from 30. And finally, tan of 60 is going to be root 3 over 1, which is just root 3. And again, root 3, far better answer than the decimal version of root 3, which is 1.73 decimal. So these numbers of what are sine, cos, and tan of 30 and 45 degrees and 60 degrees turn out to be very important in math. You'll see a lot of 30s, 45s, and 60s in real life applications. But also just in a lot of trig questions as you go forward in Math 20 and 30.